let's get started. All right. Are we ready to go to chapter 2? Get started. Wait. Hang on. I will put it down. I need to refresh your memory. Here we go. S plus 0.67 or 2/3 D less than equal to 708. 0.7 S plus D less than equal to 630. I know a lot of you, it's been a long time since you probably had, algebra or something in high school, who knows. But there were 3 ways to take two equations and figure out what the variables represent by taking the 2 equations and either using the subtraction method, the addition method, or the substitution method to solve for these equations, and you'll figure out what the variables are. If these were graphed lines, it would be where the lines are intersecting. So, the key is, and you have this on your next quiz, and you can use any one of these 3 I'm about to show you, the addition method, subtraction method, or substitution method. When I go through these, you figure out which one you find easiest, and I posted an example of all 3. Where is that? Is this it? Right here. All 3 of them, so you have examples of all 3 that you can have right next to you while you're taking the quiz. But you'll have a choice which one you want to use, and I hope everybody's using different ones, which is fine, whichever one you find most comfortable. Let me see, I'm going to start with the substitution method. No, I can tell already that I'm Subtraction. Subtraction? Okay, but here's the deal. When you're using the subtraction method, you're subtracting the 2 equations on purpose. You want to eliminate one of the variables by getting 0. So this would be 1 minus 0.7, that won't give me 0. This would be 0.67 minus 1, that won't give me 0 either. So when I want to use the subtraction method, I have to change one of these equations in some way so that when either the d's are subtracted or the s's are subtracted, it will give me the 0. I'm going to multiply the top equation by 0.7, which will make these 2 the same, and then when I subtract them, I'll have a 0. Does that sound right? So I'm going to go 0.7 times, and don't forget, you can't just multiply one part of this equation by 0.7. Anything you do to part of the equation, you have to do to the whole equation. Left side, right side, everything in it. It's really the same equation because you changed everything exactly the same way. 0.7, someone's got to help me on this, 0.7 times 6.7. Get a calculator out. Ready? 0.7 times s, I'm going to put it right here below here, is 0.7s. 0.7 times 0.67 is help me out. 0.469. 0.47, I'm rounding. D. What?
46.
Oh, it's 0.7 times 0.67.
0.4.
0.4, what's the next digit?
469. You're right.
Okay, 47. D. Everybody understand what I'm doing? 0.7 times 1s is 0.7. 0.7 times 2/3 d is, now we're at a little less than a half of a d. Now, 708 times 0.7. And look, I'm changing this to an equal sign just for visual effects. Hang in there. 0.7 times 708, give me, Bailey, where are you?
495.6.
495.6. Thank you. Give him another 10. There we go. Now, this equation is this equation. I have 2 equations here. I'm now going to use the subtraction method. 0.7 minus 0.7, I did that on purpose to get 0 s's. That's the whole point. We're canceling out one of the variables. 1d minus 0.47d is 0.53, correct? D, right, is 1d minus 0.47d. Am I right? And then I have 6, I'll put an equal sign for visual effect. 630 minus 495.6 is 130. That's 134.4. Help you out. 134.4. Now look, I only have one variable in. I can tell you what d is going to be. Divide both. I want to get d all by itself, so I'm dividing both sides by 0.53. And I get d equals 134.4 divided by 0.53 is going to be 300 and what?
253.1.
Right? What's the next one after that one? So I have to check it.
7.
7?
No, yeah, point
107?
Yeah.
Okay, all right.
I got 45.
Whoa.
I have 134.4 divided by 0.531, which is.
Oh, you're adding a 1 there?
Yeah, because earlier you
All
rounded
right.
into this.
However many digits you want to go, don't forget, it's up to you how many digits you want to go. But I'm looking to make sure you rounded correctly. Whichever one you rounded at, as long as it's correct, I'm okay with it. Where am I at? 253.11 is D. We just found what D is. We made a mistake here somewhere. From rounding, I'm sure. And now I'm going to plug this in for D in either one of these equations. I'm going to look to see if I wrote down the equation correctly. It does look weird. All right, let's keep going. 253. I'm going to just call it 253. There's something here. 253 for D in either of the original equations. Either one, you'll now know what S is. So I'm going to go to the top one. S plus 0.67 times. I'm now plugging this in for D. 253. What was the right side here? What is this? There it is. Equals 708. Someone help me out here. S plus, what's 2/3 of 253? About 1.
169.51.
Say 1.
169.51.
169.51 equals 708. Now subtract 169.51 from both sides. I can tell something's off here. 708 minus 169.5. Tell me what it is. Come on.
538.
538.49.
Yep.
0.49. Look at this. D is 253. S is that. We made a mistake. Is this the same equation up here? 0.7S, is that what we got?
No.
0.7
See, we,
plus D
that's
equals
630, and then what's this one? S, maybe it's just our rounding, I guess. Just our rounding, those are the same numbers, not
That
the-
one's 0.667, not 67.
Ah, maybe that's what's doing it, huh? I don't know if that's why we're off, but it might be. Doesn't matter. You get the concept? Did you see how I got to it though? I had to change one of the equations so we have the ability to subtract and eliminate. Here's the deal. The addition method is exactly the same way, but when you add them, you want to eliminate a variable. So at this point, even let's say we stay with the same change, but if I add these, I'm going to get 1.4s. You see what's happening? So I'm going to do this again, but watch. I'm going to multiply by negative 0.7 all the way across instead of positive. Watch. Instead of this, I'm going to get, ready? Negative 7s. Right? That doesn't look like an S. There you go. Plus, what do we get? 0.7 times 667. Now what is this? Now that we changed it. 0.4. Nobody. 47D. Negative though. All right. Negative. I lost some people. Negative 495.6. Hold on. Go ahead.
Where
You
did
ready?
that come from? What formula are you using?
Here's what I'm doing.
Okay.
Here's the same two equations.
Okay.
But for me to be able to add these two equations and eliminate one of the variables, I have to have either a negative 0.7s here, or I have to have a negative 1d here, or a negative 0.6. When I add them, you have to have one positive, one negative, so they zero each other out. So in this case, negative 7 times s, or negative 0.7 times s, let me get the point on there, okay, and then negative 0.7 times 0.66 is a negative 0.47, and negative 7 times 708 is a negative 495.6. These numbers are the exact numbers we have right here, but they're all negative. That's all that's happened. Everybody with me so far? Now I'll put this equation back, the one we didn't change, 0.7s plus d, I'm using equal just for a minute, 430. Everybody see this? Now I am adding these two equations. Negative 0.7s plus that is 0. Help me out now. Negative 47 plus 1 is a positive 0.53d, correct? Negative 495 plus 630, no different from subtracting, is 134.4. We divide both sides by 0.53 because now the negatives are gone. And we get D equals the exact same answer, 253. And then we plug 253 in either one of these original two equations. Which one did we use here? The top one? Let's use the bottom one now and plug that in. So I'm using 0.7s plus again, I'm right here, 0.7s plus D, 253, and then we have equals 630. 0.7s plus 253 equals 630. All I did was put that in for D in this original equation, the opposite one we did over here.
Wait, don't you need the times part?
What? Right here, 0.7 times S
Oh, I
plus
see.
D, which is 251 times D, so just 1, and then 630. Now, I subtract 253 on both sides, and I get 0.7S equals 630 minus 253. All together. What is that? 300 and, how much? 377. Now divide both sides by 0.7. And you'll get S equals, I don't even have to do it, it's going to be 538.49 again, or something close to that. Same answer. There's two of the concepts. Some people love the substitute method, because then they don't have to change one of these. You know, so let me show you the substitute. I'm going back, I can't remember if the camera can show that one or not, so I'm going to go over here just in case. So this time, I'm going to take the equations, the same two equations, and I'm just going to get one and get it to where there's only a variable by itself on one side. The same equations again. 0.7s plus, what is that, D, less than or equal to 630, I think it says. And this says S plus 0.667D less than or equal to, what is that, 708? Your substitution. Since I have to get a variable all by itself, I notice this variable has is a 1, so this would be the easiest one to get by itself because I only have to move over the stuff next to it. So I'm going to go ahead and subtract 0.667D on both sides. And all that will be left on the left is the S. S, and I'm changing this to equal just for visual, no big deal. 708 minus 0.667D. So all I did was take that equation, I got one of the variables all by itself on the left side. Now I go to the other equation and I plug in for this variable, this part. So the part that's on the right side gets plugged in for that variable in the other equation I did not use. So I'm plugging all of this in to that S right there because I did not use that equation. So now we have 0.7 times, plugging this in, 708 minus 0.667D plus D, 1D, equals 630. There's only one variable now. We're going to be able to solve for D, and we're going to plug that D in for S into either one of the original equations. And we're going to get the exact same answers we got over there. 0.7 times 708, calculator. Say it again. 495.6. 0.7 times negative 0.667. That's going to be the same we got before. 0.4.
669.
Whoops, this is minus. Hang on. Minus 0.4669.
4669.
D, right? And then we have plus D still right here, equals 630. I'm going to do two things. Put like terms together. 1D and a negative 0.46D leaves me with 0.533. Is that right? Is it? 0.533D. Putting these like terms together right here. Now I'm taking 495.6, subtract it from both sides, and I get minus 495.6. So is that 100 104.4? Anybody? Nobody. 630 is 100, say it again.
134.4.
134.4. Now I'm dividing both sides by 0.5333, and D is going to equal the same as it always equals, which is 538. Is that right? Oh, yeah, that doesn't look right.
No, it comes out to 250.
What does D equal over here? 253. Excuse me, I was reading the other one. So this should be about 253. Is that right?
Yeah, if you, yeah.
134 divided by 0.533. And then now, I have D. I go back to one of these original equations, either one, doesn't matter, and I plug 253 in for D, and I'll know what S is. Let me explain this again. Subtraction method. We didn't have the same number on one of the variables, so when we subtracted, we couldn't eliminate one of the variables. So we had to decide to change one of the equations so that we could get one of the variables to have the same number with it. So when we do subtract it, one of the variables are gone because they become a zero. And then we solve for the other. The addition method, same situation. We didn't have a variable that was exactly alike, so that when we added, it would zero one out. So we had to change one of the equations to get it. So when we do add them, it would turn one of the variables into zero. So we just use the opposite of the subtraction method. Instead of multiplying by 0.7, we multiplied by negative 0.7. So we got negative 0.7s on that top equation. 0.66 times negative 0.7 is negative 0.47. And then we have 708 times negative 0.7, negative 495. Then we add. We got rid of one of the variables, solve for the other. Every one of these, once you solve for one variable, you go back to either one of the original equations, plug it in for that variable, and you'll know what the other variable is. The reason this is important is in this chapter, you're getting to a point to where you're going to learn. This is awful, by the way. In real life, you never ever have to graph equations. Software is going to do it for you. But the reason I keep this chapter in my lecture is because when you're sitting at the table, when you're a real manager, and these are being used, and believe me, every big company is using these, you need to understand what the software is doing to get that optimal solution. By understanding what it's doing, you'll be able to get input. Hey, what if we get a hold of that supplier and we're able to get that cost, material cost for this new item we're about to make, if we could get it down just a little bit, what we're going to learn in chapter 3 is what effect will that have on the optimal value. That's the whole point. By the way, I want to review what the main purpose of all this you're learning in this class is for. And what the main purpose is. Now, I'm even going to make sure this is on your mind. The main thing you're learning in this class is when you're in the business world, there are thousands of companies that are not using this. And I guarantee you, any company that's not using this kind of stuff you're learning in this class, they're throwing away money. Money's being wasted every single minute. And every big company knows that it's these kind of equations, all these things, every one of these chapters are big businesses use to make sure that the decision making is all about the optimal and not wasting any money. To maximize that profit. That's the key. That's what all these are about. So, the software is going to do this for you and find that optimal solution. But for one quiz, you have to be able to do this. This will not be on the final. It's all about getting past this next quiz on substitution method, addition method, or subtraction method. Whichever one you felt reached out to you a little more than the others. Pick that one and focus on that one. And circle that example, because when you get to that part on the quiz, look at that example and follow the one you felt you understood the most. All right, now, you there? Now, chapter 2. So just refreshing your math. By the way, I think we made a mistake.
It's a rounding error, I believe.
Rounding. Okay, you ready? These slides, this is all what you read at home before you got here today. Blah, 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 blah. Important stuff here, by the way. That one, slide 3. Blah, 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 blah. Ready? Everybody got this? Plus it's on the example anyway if you don't have it. I got to start erasing this. We got a lot of work to do. You ready? You're at this company. I want you to picture this. This company makes golf things, and they're saying, hey, we now want to get into the golf bag business. What's the name of this company? Car Incorporated, right? Nice, easy name. We want to get into the golf bag game, and this manufacturer says, look, if we have, is it a distributor? Who is it? I can't remember who it is. Our distributor. We've been talking about this for months to our distributor, who then dishes it out. We sell to them in big quantities. They separate it out. They sell it to the retailers in smaller quantities with a markup, so they're making money on it. But we're the manufacturer. This is called selling wholesale. When you ever see someone say, I'm selling wholesale is because I'm selling to somebody else who then sells it on past them. It's called the middleman, the distributor, in most cases. Our distributor said, when you're ready to get in the golf bag business, we're going to buy, for the first 3 months, we'll take all you can make. Those are the best words for a company to ever hear. Because the risk of starting a new product is so huge that by a distributor saying, we'll take all you can make in the first 3 months, think about it, the risk reduction, knowing that you have a contract in place for all you can make in the first 3 months is huge. Having no contracts in place, no one telling us they'll take these golf bags is a lot of risk. And you're looking at starting a new product over $1 million. And then yes, it's not your money, it's the company's money, but you need to treat it. If you're part of the management team, you got to look at the company's money as if it is your money, and you want to protect it. You don't want to throw it away. You're always throwing away enough of your own money by living over your means, right? But the company is all about living under their means and creating profit. When they do these golf bags, there's 4 departments these golf bags have to go through. And here comes our limitations, because our employees can only make these golf bags in so much time. They got to go through cutting and dyeing. They got to go through sewing. They got to go through finishing. They got to go through inspection and packaging. And when they go through those, from tons of meetings, I have your management, you're the numbers department, you are working closely with the foreman of production. They're bugging the heck out of you because there's something they need from you. I want you to, as I'm reading this, I want you to tell me, what is it they're waiting for? Why are they waiting, just not making production yet? What is it they're waiting for you to tell them to do? As I read this, we're going to make 2 types of bags, standard and deluxe, and here's how much time of an hour each bag will take as it goes through these departments. Now we're going to use an assembly line process most likely. And if that's true, we're going to focus on making one type of bag, stop when we get to that point, change everything, and now we make the other type of bag. And production's just waiting. The foreman just told you 3 times, I gotta get the employee scheduled. What are we gonna do? They're waiting for something from you. What is it they're waiting from you? You go, what is it? That's right. Hang on. Everybody got it. Hang on. So power production is constrained by some limitations. Are you ready? The hours available in each department. Even if we have overtime, whatever the situation is, there's only so many hours for a 3-month period. The hours are going to be, manufacturing estimates 630 hours in the cutting and dyeing department. That's it. Whatever bag we're making, however many we're making, we can't go over 630. I always love to start my constraints when I read a sentence like that, because I know it's a limitation. And all of these sentences I'm reading to you, you should be saying to yourself, that's the right-hand side of a constraint, but is it a less than equal? Is it a greater than equal? Is it an equal? It's a limitation. We have no more than 630 hours in cutting and dyeing. Less than equal, greater than equal, 630. That's right. 630 is the max. So however we're going to make of each one of these bags, we can't go over 630 hours in that department. And look at this, sewing. 600 hours. That's it. No more than 600 for this process. Less than equal, greater than equal, or equal? Less than equal. 600. That's all that's available. We don't have to use all 600, but we can't go over it. There's 708 hours in finishing. That's all. 708. Less than equal, greater than equal, or equal? Less than equal, 708. And last but not least, in finishing and inspection, I'm sorry. Wait, did I skip finishing? No. In inspection and packaging, there's only 135 hours. Very little hours there. That's all we have. Less than equal, greater than equal, or equal? Very good. 135. We got the right-hand sides. These are your left-hand sides. This is how much time it's going to take for each one of these bags in each one of these departments. Haley said he thinks the foreman's been bugging you about getting to them how many of each bag you're going to make so they can start scheduling employees. And if you don't get to them by tomorrow, they're starting production of a bag and they're just going to make 100. And then they're going to stop. If you still haven't told them how many, they're going to stop, change things, and make 100 of the other bag. Money will be wasted. Because they should never want to change that until they've got exactly the amount of bags of one bag, then pay only once to change everything, then make the exact amount we need of the other bag. Only change it once, because if you make 100, change everything, make 100 more, oh, we didn't make the right amount. You got to pay to have all the setup done again and go back to the first bag you were making to make more of them. So that's why it's so important that they know, that the foreman knows how many of each bag is going to be scheduled for the next 3 months, so I can work out all these employees' schedule, and I can make that moment where we got to switch everything over at the right time, so we only make the perfect amount and only have to switch everything up once. So we're going to go ahead and give an S to standard bags, and we're going to give out, what's the other one? Deluxe, D. Those are your decisions. From this point on, when you read one of the stories, I gave you the variables before, but at this point, you now have to say, here's the decisions that have to be made, and you're going to represent it with a variable, and you're going to define it. It's going to be like this. S equals number of standard bags, blah, 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 blah. What's the other one? D equals number of deluxe bags, blah, 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 blah. Deluxe, there you go. Here's the left-hand side. You now know your variables. For every standard bag that goes through cutting and dyeing, in which we only have 630 hours available, it's going to use 7/10 of an hour. I like to use decimals, so that's 0.7. You ready? 0.7 times however many standard bags, plus how much time does deluxe bag take? 1 hour. I don't put the 1 there. D. 0.7 S plus D less than equal to 630. You just wrote the constraint using the variables that represent the decision of how many of each bag that we need to let the foreman know to schedule the employees for. So we'll have one set up. Sewing, we said is less than 600. It takes standard bags at a half hour. 0.5 for standard bags, plus how much time deluxe is 5.6. Give me a decimal on that. No, 0.3, is that it? Really? 5.6? Yeah, sounds right. Sorry.
Repeating.
0.83 D. 0.5S, 0.83 D, less than equal to 600. Only 708 hours in the finishing department. We have 1 hour for every S, plus 0.667. There's our thing right there. D for every deluxe, but we can't go over 708 hours. And 135 hours all we have in the inspection and packaging. 0.1 is all standard bags will take. And what is that? Plus 0.25 times however many deluxe bags. 0.1 times however many standard bags. 0.25 however many deluxe bags. We can't go over 135 hours. Now what you have here is really a whole bunch of lines. And the optimal solution of how many bags we make has to satisfy every one of those. All of them, not just one of them, not most of them, not 3 of the 4. Every one of them have to be satisfied, or it's not the optimal solution. Or we're going to misallocate how much to schedule each employee for production. So now you're going to learn next Thursday or Tuesday, I can't remember which, how to enter this into the software. And I think I already showed you how to enter it into the Excel spreadsheet last week before the quiz. Did I show you how to enter it into the software too? I did? I'm going to show you again when we get to that point. But you need to understand what the software is doing. What the software is doing is it is doing, and you can only do this when you have 2 variables, but this is leading you up to where we have multiple variables. But you have to graph every one of those constraints. When was the last time you graphed lines? Has it been a while for a lot of people? Long. Just one person, it's been a long time, the rest of you? No, hey, who hasn't graphed a line in a long time? Okay, most of you have. I'm going to simplify it. The key to graphing a line, are you ready? is you put a 0 into the equation for one variable, solve for the other. Then you take a 0 into the other variable for the same equation and solve for the other. And then you graph those points. Now let me explain. What I'm saying is, what do we got? S and D?
Yeah.
I'm making a mini graph here. This is not, I'm making S right here, and I'm making D here. When I plot points, when I describe points, the left digit of a point is representing the S. The right digit is going to represent the D. So right now, this is S, this is D, and then I'm going to put it right here. S, D. I'm going to put a 0 in for S, figure out what D is. I'm then going to put a 0 in for D and figure out what S is for every one of these equations. Every one of them. One at a time. Start at the top.
Do you make it as an equal sign then?
You make it an equal sign. You don't have to, but psychologically, visually, you're plotting the line. Then you go back to look to see if it's less than or greater than for the next step. But right now, you just assume like it's an equal sign because you're trying to just plot a line on the graph. Now, I can't remember what these numbers go up to, but I'll put it in once we get there. Let's see. The top one, 0.7s. So this is 0.7s plus D. I'm making it equal, just for visual effects here, 630. You ready? Here we go. I'm going to do this top one first, which means I'm putting a 0 there on purpose. I just canceled that out. And what do I have left? D equals 630. There we go. When S is 0, D is 630. 100, 200, 300, 400, 500, 630. 0, 630 is right there. When S is 0, D is 630. There's the D. Now I'm putting a 0 in for D. Doing the same thing. Going back to the original equation, 0.7s plus D equals 630. I put a 0 in for D right there. Cancels out. I get 0.7s equals 630. Take 630 and divide by 0.7. Tell me what you get. I think we did it over there already, but what is it?
900.
900?
Yeah.
Now, this equation, the same equation, crosses the s-axis at 900. 900, 0. So that means it's crossing this axis. Now, your graph has to be exactly the same way, the same numbers. 1, 2, same distance apart. 3, 4, 5, 6, 7, 8, 9. 900. And now, you grab a straight edge, which I don't have one, so I'm going to eyeball this. Hang in there with me. Hang in. Boy, tell them off. Oh, that was awful. Pretend that's crossing that dot. Right? You connect the dots, but you go past them. This line extends forever. Now look, there's other quadrants down here, right? And your line, your dot may be down here or something. But when you connect your dots, you extend that line into this quadrant, because your optimal solution will always be in this quadrant, never here, here, and here. So if I'm connecting these two dots, I'm making sure I'm extending it up in here, because your optimal solution will be up here. So now, I just graphed that equation. Look at the original equation. Is it less than equal or greater than equal? You'll get so used to these that you won't have to do this next step. So if I don't see work on it, it's acceptable. But really, if you're just getting familiar how to do these, you pick any arbitrary point on either side of that line you just graphed, and you see if it fits that equation right. My favorite one that I almost always use is that point right there. This is usually 1, 1, but in this case it's 100, 100 is that point. I go back to this original equation right here. I put 100 in for the S. I put 100 for the D, and I see what happens. 0.7 times 100 is 70, right?
Wait, what did you say we're doing?
Here we go. I pick any arbitrary point you want on either side of this line. This is to determine which way the shading goes. You pick any point on either side. Boy, I know a lot of you already jumped ahead of me and knows what's going to happen, so now I'm picking one out here. So we can all learn this lesson. Where am I at? 1, 2, 3, 4, 5, 6. That's about 700. We'll call this 700 1, 2, 3, 4, 5, 500. So I picked this little point out here. Arbitrary, doesn't matter. A point on either side is so much easier to do one row. I just want to tell you that. I'm plugging in, I forgot the numbers already. 700 and 500 now. Someone help me calculate 700, 500. Oh, this is easy. 70% of 700 is 490, plus 500 for D is 500. What does 490 plus 500 equal?
Bigger than 630.
That's right. It equals 990? Now look at this equation. Is 990 less than equal to 630, yes or no? No. So you know not to shade that way. Had I did this with 100, you'd be saying, yes, it is less than 630. So then it's telling you to shade this way. If the answer is no, it's telling you to shade the opposite way of the point you just checked, which would also be this way. So you'll get so used to these, you don't have to figure out a dot. You'll be able to say, oh, it's got to be shading this way, it's a less than equal.
When you have a series of equations like this, how do you know which one to graph?
You have to graph them all.
Okay.
Have any equation in this chapter given to you on this next quiz, it will say, graph the first two constraints, or these two constraints, you graph these three constraints. You know in a quiz, I'm not going to have you graph like three constraints, but
Would you do them on the same plane so you can see where you overlap?
absolutely, that's where we're headed. I noticed you didn't read the PowerPoint before you got here. Just kidding, stop. I'm just giving a hard time, come on. Some people fall asleep, they need that. You ready? We're now shaded that way. The second equation, the process I just showed you is exactly the same. Plug a 0 in for one variable, solve for the other, put a 0 in for the other variable, solve for the other, put the dots, and figure out which way it shades. Now do it on the same graph, even though you see right here, wait, do we have the right constraint? 0.7 S1D less than or equal to 630? 1/2, 5, blah, 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 blah. We didn't talk about this yet, we're coming back to that. Here's the one we just graphed, right? 0, 630, and 900, 0. We just graphed this one. We just found out, look, they're picking the point 200, 200 here, plugging it in. Will they get a yes or a no? When they plug this into that first constraint, will it end up being less than 630, yes or no? Yes, it will. So they know to graph this way. But if they pick the point out here, the answer would be no. So they go, oh, we shouldn't be graphed. We shouldn't shade that way. It will be the opposite. If it's a no, it's the opposite. If it's a yes, that's the way you should shade. And so we shade it in, and it looks like this. We do the next equation. We get 0, 1062. Put that dot. We get 708, 0. Put that dot. Connect the dots. Let's go 100, 100. We put 100, 100 in the second equation. 100 times 0.5 is 50. 100 times 0.83 is 83. 83 plus 50 is 133. Is that correct? Is 133 less than or equal to 600?
Yes.
Then that's the way you would shade. See that? It's so easy if you just go with 1, 1 or 100, 100 every time, and it will be quick to show which way to shade. Jump in.
I went 0, 0.
I tend not to use 0, 0, but just in case. There's special circumstances where 0, 0 will cause a problem. It's usually very reliable, and on a quiz, if you want to use 0, 0, it's probably going to work. Once we get past this chapter, you're not going to care. Because the software is solving it from now on after we get past this chapter, or Excel is solving it from now on. We're going from you understanding what happens when the software or Excel takes place to analyzing the results in the next chapter of what the software or Excel is giving you. Okay? But if you want to use 0, 0, I'm not requiring you to explain to me how you decide which way to shade, because I know a lot of you are going to quickly get to the point where it'll be obvious which way to shade. You may not do any work at all. So that you know you're doing it right, you may do that just to make sure you're shading the right way.
What kind of circumstance has it where you're shading
The opposite way?
one way for one graph and the opposite way for
Oh, it happens.
another graph?
For a line. He's saying, what if this one were going this way, if this one's going this
Yes.
way? And if this one were greater than or equal to, it would be going that way.
Okay, so it's like, yeah.
So when you plug in 100, 100, you'll go, no, it's not greater than equal to 600, so you know to shade the other way.
So is it like maximizing versus minimizing?
Sometimes. We are happen to be going on Thursday into one, this one's a maximize. We're gonna do a minimize on Thursday, in which the shading does happen to go that way. So you're gonna see an example of that on Thursday.
Can you run just really quick by the shading thing one more time?
Okay, you ready?
Yeah.
What about the graphing? Like,
That's perfect.
you can get to these 2 points, right?
Yeah.
And then you connect the dots, right?
Yeah.
And then you pick a point on either side, arbitrary. Can you see these numbers?
Yeah.
What point would be like right there or right here? Do you see that number? Anybody tell them?
Was it 200?
200, 200. So let's say it could be any point you want. I'm going to go down here and pick 100. Whatever point you pick, there's 2 numbers to it. The S and the D. So you plug in 100 in for, which line's that? This one? Which one are we doing? We're here or here? Second one? That's this one. So you plug in 100 there. Then you plug in 100 there, and you're trying to figure out, will that make it less than equal to 600 or not? 100 times 0.5 is 50. 100 times 0.3 is 83. I added them. 133, and I said, oh, it's true. That point should be in the shaded area. So you go, I'm going to shade that way. But if you pick the point out here, it would be, no, that's not less than equal to 630, so I shouldn't shade towards that point. I'm going to go the opposite way. So you only need to check one point, and it will tell you either you do it that way or do the opposite. So everybody can graph a line. Everybody knows how to figure out which way to shade, right? Here's the third one. Right? Let me see. All right, is this the second one or is this the first one? Sorry about that. This is the second one. Here's the third one. Here's the last one. If we put what's the last one? Less than or equal to 135? If we put in a 0 for S, and we did the math on that last one, we would have 0 here, divide both sides by 0.25, 135 divided by 0.25 equals 500. Put a dot at 0. Is that 500? I can't even read it. Put a 0, 500, put a dot. Now we're going to put a 0 for the other variable. 0 right here, that's gone. 0.1 S equals 135. Divide both sides by 0.1. S equals 1,350. So you put a dot at 1,350 times 0, which is right there. You connect the dots. I'm going to pick 100 and 100 because I always do. 100 times 0.1 is, what is that, 10? Is that right? Anybody? Is it 10? So 100 times 0.1 is 10. 100 times 0.25 is 25, I believe. Is that correct? I add 10 and 25, I get 35. And now I ask the question, is that point less than or equal to 135? And you're all shaking your head, yes. So I'm going to shade that direction. Get it? You should be doing this on one graph though, not on 3 graphs. So when you do your shading, do it lightly. Do it lightly, because there may be other lines involved. So do your shading lightly, and then you get here. And now you have all this other shading. You have shading here, but you're going to darken. This is the line. See this one here? Look at that right there. Look at this one right here. Look at that one. This is where every shade overlaps. Let me say it again, because this is so important, you guys. Once you have all the graphing done in the shading there, you have to darken the outline of the feasible region, which is where every one of those 4 shades are all overlapping. Not just 3 of the 4, not 2 of the 4, every one of them have to overlap. So you notice this little triangle here would not have every one of them overlapping. That little triangle would not. It would leave this one on. That one too. Only from here to here to here is all the shades, all 4 of them are overlapping. You've just found the feasible region, which is where the optimal solution for how many standard bags and how many deluxe bags we need to tell them to make is somewhere right there. We've got it down to that area. Now I want to add to this story. We didn't just get it down to that area. Your optimal solution is always at an extreme point, touching the area. Everybody understand what I just said? How many extreme points do you see? Those who think they understand what I said. Oh, that's way too long. Is that 2, 3, 4, 5, 2? I hear 2. I hear something. I heard something else. 3. I heard. Give me throw a number out.
Well, if it's an extreme touching the area, it would basically be any point along the border.
That's true. That would be it. Any point along the shaded border. You see. How many? How many? Give me some numbers. Not a lot.
Maybe just means,
I'm sorry. A point is where 2 lines are crossing. I hear 2. I hear 100. 2 more. 4. Not one of you were right yet. Not one of you. I think. I haven't looked at this. I forgot how many. But I know it's not 2. Okay. Good, Mike.
Okay, if you're trying to figure out like
I could give you a number. You're going to learn one. How many?
700.
No. 2 lines have to cross. Look at this region. You ready? Some of you said, oh, there's 2 lines crossing right there, correct? That's 1. 2 lines are crossing right there. 2. 2 lines are crossing right there. 3. 2 lines are crossing there. So who said 4? You're wrong. You got 2 lines crossing right there. That's 5.
it's always.
I keep
is
having
it
to say
always
that.
odd?
I'm sorry. I'm picking on him. I got to pick on something else. Go ahead, son. Go
Is it
ahead.
always odd?
It's always on one of the extreme points. One of those extreme points. In the old days, we got lazy with that. You weren't born yet. But when I was learning this stuff, we got lazy and just said, let's just take every one of these points and plug it in to the objective function. Since it's a max, whichever one of those 5 points gives us the biggest objective function is our optimal solution. You are dead right. That's exactly how you can solve it. Bad news is, you can't visually tell me what that point is, and if you are, you're wrong. There's no way for sure you'll get that right. You can't visually tell me what that point is. You know that point because you graphed that point. You know that point because you graphed that one, and that one's pretty easy. But these 2, there's some work involved in figuring out what those 2 points are. You'd have to say, well, what 2 lines are crossing there? What line is this one right here? C and D. Whichever one of these are C and D. And then, what's this other one here? Hang on, let me follow it. I and P. So one of these are I and P. And you would take these 2 equations, I forgot what it is, C and D, I and P, and you would either take those 2 equations and use the subtraction method, the addition method, or the substitution method, and then you know what that point is.
24.
And you would have to do it again with this one. What 2 lines are crossing there? Addition method, subtraction method, or substitution method. Here's a shortcut, so you only have to do this once. Kind of. To find the optimal solution, you now go back to the objective function. We're going to talk about the objective function. How much time we got? Well, we're going to talk about the objective function and figure out what it is. Then you graph it. Now, when you graph your objective function, it could end up anywhere. It could, and a lot of people like use dotted lines to say, this is not a constraint, this is my objective function. I like to just use a really dark line. Let's say the objective function lands like this. Okay? So, hang on, let me do it on this one. So let's say it's like this. That objective function is not even close to one of those lines, one of those extreme points where 2 lines are crossing. Let's say it ends up right here. Then you take a straight edge, folder, anything, and you stay parallel to that objective function, and you move one way or the other. And when that straight edge is either touching the first or the last extreme point, you're going to see all this demo. I just want to let you know, right now, if you're getting lost, you're going to see, you're going to hear all this part again on Thursday. But when you move that objective function line parallel, it's either going to, in this case, because it's going to be a maximization problem, you're going to end up going this way. Because it's a max problem, going this way, these extreme points will give you a bigger objective function value than that point would, obviously. So we're going this way with the objective function, and we're leaving the feasible region. Oh my God, look, it's past that point. It's already past that one. It's between these 3 now, and you're moving it, and when you get that straight edge to where it's only touching one extreme point, and the rest of the straight edge is out of that feasible region, except for one point where it's like a teeter-totter on it, you just found your answer. That is the optimal solution, right there. And you say, well, let's say it's right here. Well, what two lines are crossing there? Oh, it's, what did you say, 1 and 4? Oh, it's these two, maybe, whatever two it is. Now the next step is to use the addition method, or the subtraction method, or the substitution method, but only once. Figure out what that point is, and you just found the optimal solution. You got a lot more work to go past that, so that's why this may take 3 lectures. But at least at this point, you know what's coming, right? And right now, all about today, that you may not hear repeated too much, is can you formulate a linear programming problem to find the variables, figure out the right side and left side of the constraints. And then we'll get to the objective function. Then, can you graph the constraints? This is where you need to be after today. Can you take a constraint and put a 0 in for one, find the number, put a 0 in for the other variable, find the number, graph the 2 points and connect them, yes? And then figure out which way to shade. You've got to be at the point where you can graph every line and get the shading, and then highlight the borders where all the shading for every constraint touch each other overlapping. Get to that point, and then you should be able to tell me how many extreme points. Wait, we're not done yet. Hang on. No. Hang on a minute. Hang on. Oh, okay. I know who's here. I passed back quizzes. Whoever I got the quiz. You're gonna get your quiz on the way out, okay? You know, the self graduating is taking attendance. I'm taking attendance every day, whether you realize it or not. All right? Don't skip. I always skip. But don't skip. 508. Anything you want to talk about? Anything? Hang on. Give me a second. I want to show you something. Okay, hang on. I want to show you something. Hang on. We have hang on. I want you to see something here. I was grading your quizzes over the weekend. Where am I? Oh, what happened? I never turned it off the whole time? Okay, hang on. I was grading your quizzes. Your quizzes on Thursday, right? So I'm hustling Thursday night trying to get your quizzes graded, and I'm hustling Friday. Then all of a sudden it came to almost noon on Friday, and I had to stop your quizzes. And I got to the point to where there was only like one problem left on everyone's quiz. So when I grade your quizzes, like an assembly line, I do the first problem with everybody's, not looking at names. I took out half point. I take the same half a point off, the same quarter point on everybody's, like an assembly line, trying to make sure that I grade them all exactly the same. Then I do the next problem or two, then I flip them over, go like an assembly line, so I'm grading them the exact same way, and I had to stop. And then the online students, just like you have all your little folders there and all the crazy stuff I do to help you resist temptation of possibly having a situation, right? In their case, every online student had to communicate with me video conferencing, FaceTime for a lot of them. I would put my phone on the tripod, and they have to take their tripod and put it back here, point it at their computer and their work area. I email the quiz to them, and I can watch everything they're doing. I can see everything because the camera's back here. There are 55 online students. I want you to see my schedule real quick. How many is that on Friday? 10? Saturday, 11:30, all the way. 22 on Saturday. Look at Sundays. 22 on Sunday. Look at Monday. What were the other ones? 3 on Monday. It was a weekend of hell. I barely got lunch. I barely got dinner. I realized I had to surround myself with protein bars and Kind bars and something to survive because I couldn't get away. One after another, because I want to have them realize that I'm taking away the temptation to cheating also. I want a level playing field for everything. And I want to tell you something. There were 4 students in the online program that didn't see this coming. And how do I know it? Because when they set the camera back, they have this, they just like a deer in headlight look, and they're looking at it, and then I see that they're not looking at any PowerPoints. They're not looking at any homework. They're staring at it and writing, and nothing's happening. And that's my cue that this person had no intention of doing that quiz with the materials that were posted on Blackboard, but they had a different plan in mind. And they just go, whoa, my plan just got thrown out, and I've started the quiz that's only 27 or 30 minutes. What do I do? They instead say, I just go ahead and ruin my grade the best I can. That's what they did. And I hope that they will feel like, okay, the amount of work it would take to cheat my class is more work than it would take just to apply yourself. I break these lectures down into little bits and pieces that should be understandable by everybody while you're sitting here. The tough part is, once you leave, I know it's starting to leave your mind right away. And when you go to attack homework, and you haven't, in the lecture left your mind from 2 days ago, the key is, what is it that will refresh your mind as to what you heard, so you can do the homework, so you can do the quiz. That's what you need to get to. That's what happens in the working world. I had a list of things every day I had to do. It was all about, where do I find the information to get all this done as fast as I can, so I can play around for the last couple hours at the end of my day. Because I used to be the king of Minesweeper. Thank you. My staff got me a t-shirt, king of Minesweeper. At the last 2 hours of workday, I just optimized my abilities. All right, guys, I will see you on Thursday.